Hi, and welcome to Pole Shift News. Big thanks to those of you that have supported the channel over the last few days. You know who you are. I don't think there's any need to go any further than that, but say thanks. I think there's a general misconception with the understanding of magnetism. And the reason why I say that, there'll be a little experiment I'll show you with a couple of magnets in a minute, just to rebut what I've been saying about the poles breaking apart over the northern hemisphere. In particular to these two regions which are slightly purple, which is an indication of stronger magnetic fields, or in this case, because it's a temperature model, these are the colder regions, but we know that these regions match up very nice on a magnetic anomaly chart of the Earth as to where the most densely populated magnetism is. So yes, it is cold on this chart in those regions than any other place, but it's also where the magnetic fields are stronger. You'll note in this region here, a couple of years ago, it was more over here, these two regions, and over here. And yes, we've still got this region in the middle, which is warmer, and that's an indication of where the magnetic fields are weaker. And that is why I suggested a few years ago now that the poles were actually breaking apart. But the misconception I'm talking about is the way we measure magnetism. You see, Earth, on whole, it has a very weak, according to scientists and their measurements, a weak amount of Tesla, or that's the measurement that they use to measure the magnetic field strength. But let's put it in simpler terms. If you was in your house, you had a compass and you had a small magnet. If you brought the small compass to the magnet, it would deflect the needle. And that would be an indication of the magnet in your hand probably is more influential on the compass, and therefore must be an indication then that the magnetism within the magnet is much stronger than the actual magnetic field of the Earth. But it's completely misunderstood. You see, if you was to walk to the other end of your room with that magnet in your hand, it would no longer affect the magnet, the compass. So something else is going on. And what I think is going on is, I think we are not understanding magnetism quite very well. I think if we looked at magnetism more in the lines of electricity, which is a form of magnetism in any case, but there seems to be this big division between the two, magnetism and electromagnetism, we would be understanding a little bit more what's going on. I think you'll agree with me on this. If I say, yes, it's a weak magnet or magnetic force the Earth is, and it can be overcome by a smaller magnet with more field strength in a close proximity. But over a whole, the Earth's magnetic field and strength is much more greater. And the best way I think to understand this is in the terms as we understand electricity. We measure electricity in volts as well as amps. Now, if I said the Earth has very little volts, and that's why you're able to influence it with a smaller magnet, yet it is hugely powered by amps, I think that would give us a better understanding of what's actually going on. I just wanted to share these thoughts with you because these are the things that I sometimes, give a bit of time to think about. The other one I wasn't intending on doing a video today, but the other one that I was thinking about was the actual dynamo that generates the Earth's magnetic field. And, at the moment we've got a separation going over the North Pole at the moment, as well as being in a pole migration. But what is actually going on in the Earth's dynamo to create such effects as what we're seeing? What actually fails during, or changes during a magnetic pole reversal? And here's another thing. We, through the experiments that I've done on this channel over the years, we found that, magnetic material loses its ability to be strong magnetic material if it gets hotter. In fact, on one experiment I introduced a neodymium magnet, which are very strong magnets, into a fire, and we got it almost red hot. When we brought the neodymium magnet out of the fire, let it cool down, it had no influence whatsoever on a compass when we brought it in its proximity. So we learned from that fact that, extreme heat will diminish the ability of material to hold on to its magnetic ability. So, I'm just thinking, we're led to believe that the core of this Earth is very, very hot, and yet still, it is able to produce magnetic currents in the dynamo to produce, a dipole, a north and south magnetic pole. And, sometimes science doesn't explain everything, and, I just have problems with that theory of the Earth's dynamo, in the fact that it is hot, and magnetism seems to be stronger in very cooler regions. And, for instance, if we look at the North and the South Pole on this Earth, we find that not only are these the poles of the Earth, but they're also the regions where we have the Arctic and the Antarctic, and they're very, very cold regions, generally throughout the whole year. And not only that, these are the regions where the rotational axes are. Now, I think that there is a link between the rotational axis, the temperature, as well as, the field strength for the magnetism around that pole. So, with the current model of what we're led to believe, and it is, at the end of the day, a theory, and even on the basis of that theory, scientists have failed. And I know people are going to say, oh, no, look at this experiment here, here's an experiment. They've failed. They have never recreated in a laboratory a system which produces molten anything rotating to produce a magnetic field. Trust me, guys, I've had a look at a lot of these experiments that these scientists have, for some reason, been funded very, very greatly in order to get these reactions to occur, so that we can understand what's going on a little bit better in our core of the Earth. Especially in the fact that it sets up the conditions to produce these magnetic fields. Despite the theory and the failed attempts in laboratories to recreate this, it's still a big mystery. So there could be something else that sets up the conditions for this planet to have a magnetic pole. So just to wrap up this video then, guys, we've got less than 40 days more of the Earth tilting to give us the winter season over the northern hemisphere. And as that takes place, we can see this cooler region progressing further and further down. We can also see these two very dense areas in purple on the map, where it's much colder, and these will be drawing out the pattern of where the Earth's magnetic fields are stronger as a result. So, we're going to see more and more stories, basically, of massive crop failure in those regions closer to the equatorial places on the Earth, such as those South China Islands, as we did last year. Now, the other day I was changing the antifreeze on the car, and it dawned on me that some of these regions on the Earth won't have any of that protection in their radiators, because simply they never experience sub-zero temperatures. So, it might be, for you guys that live in these regions, something you might want to think about. You only need one evening of sub-zero temperatures to damage engines and farm vehicles and such on your vehicle, so it might be worth, you looking into that. I mean, not only could these people be facing devastation with crop and cow losses, I don't think you really want to add any more hindrance to your daily lives with failing equipment as a result of that. So just, bear that in mind. And, we'll just see how this progresses. I'm expecting this to continue moving further south as the tilt increases to its maximum. And as a result, I dare say that there will be some, inertia of it carrying on over the 40 days, because, this is a large planet, and, these temperatures will gradually creep further south, despite the fact that the tilt has reached maximum. So, like I say, a little bit of inertia with regards to that. So, guys, I'm going to wrap the video up here. We're going to be continuing watching this as it happens over the next 40 days. There's a link down there if you want to fund some of the research we do on this channel, help support the website that we also do. And it'll be interesting to see how this progresses. So, as always, guys, link below, and you have a reasonably good week for yourselves. And as always, bye for now. Hi, and welcome to Pole Shift News. Big thanks to those of you that have supported the channel over the last few days. You know who you are. I don't think there's any need to go any further than that, but say thanks. I think there's a general misconception with the understanding of magnetism. And the reason why I say that, there'll be a little experiment I'll show you with a couple of magnets in a minute, just to rebut what I've been saying about the poles breaking apart over the northern hemisphere. In particular to these two regions which are slightly purple, which is an indication of stronger magnetic fields, or in this case, because it's a temperature model, these are the colder regions, but we know that these regions match up very nice on a magnetic anomaly chart of the Earth as to where the most densely populated magnetism is. So yes, it is cold on this chart in those regions than any other place, but it's also where the magnetic fields are stronger. You'll note in this region here, a couple of years ago, it was more over here, these two regions, and over here. And yes, we've still got this region in the middle, which is warmer. And that's an indication of where the magnetic fields are weaker. And that is why I suggested